What does deep retrofit with verified performance involve? There are 6 main steps. The first 4 are at the design stage. Stage number 1, calibration. If you start with an existing building still in use, the first step is to do an audit to understand how energy is being used. Then develop a detailed simulation model representing both the building fabric and the HVAC plant, and calibrate the model so it predicts similar annual energy performance results to the values measured or derived through the audit. Stage number 2, design. The calibrated model should inform the design of the deep retrofit, enabling the building owner to be given reliable data on the energy saving potential of different options. Stage number 3, plan for verification. To ensure the operational performance can be verified, the next important task is to produce a verification plan, deciding where meters are needed so that performance outcomes can be measured and compared with predictions on a like-for-like basis. And stage number 4, description of operations. The final key design step is to produce a description of operations, or DesOps, which describes exactly how the building's HVAC services should be controlled. The DesOps must reflect both the design intent captured in the simulation model and the actual control system in the real building. This coherence ensures the building will be controlled efficiently. Can you expect these 4 steps comprising better design and more accurate predictions to close the performance gap? The answer is they are necessary, but not sufficient. Stage number 5 of the process occurs after the renovation works are completed. It requires special efforts with commissioning and fine-tuning to ensure the building systems are working as intended and the metering system is collecting the performance data reliably. What does verified performance mean? At stage number 6, at the end of the defects liability period and with the building fully occupied, the building performance should be measured over a year. During this time, monthly checks should be made comparing expected and actual energy use for each system within the scope of the EVC. Large deviations should trigger scrutiny to diagnose faults and implement improvements. At the end of a year, the amount of energy used by each system should be compared with the model's predictions, when the boundary conditions for the simulation are set to the conditions experienced by the building during the year of measurement. The calculated assessment of the building is then categorized as verified if there are no deviations for significant end uses which exceed 25%. And a significant end use is defined as an end use with total consumptions in kilowatt hours per square meter accounting for over 10% of the total EVC consumption.